All right, today we're going to be looking at Module 1, Part 6. We're going to be finding greatest common factor and least common multiple. There's two methods I would like to show you how to find the greatest common factor and least common multiple. I like both. I like the box method as it's something new that I recently learned, and it's pretty neat as well. So the first way we will do it is using the method of primes. So we previously found prime factorization in the previous section. So we're going to start out doing that. Okay. So we're going to have two numbers, 945, and then we're going to have 5145. Okay, and these are big numbers, so I will use a calculator to assist us. I'll just get the basic calculator that's here on the computer and pull that up. Okay, so both these numbers are divisible by 5 because they end in 5. So I'm going to divide both these numbers by 5 one at a time. 945 divided by 5 gives us 189. Okay, 5 is prime, so I can stop there, but 189 is not. Now, using those rules of divisibility, if I add up these numbers, I get 9, and 9 is 18. 18 is divisible by 3, so I can divide by 3. So I'm just going to do divided by 3. That gives me 63. So this is prime. 63 is divisible by 7. It's one of those multiples. 7 times 9. So I get a 7. And then 9 is 3 times 3. Okay, so the prime factorization, we have 1, 2, 3 threes. So I'm going to say 3 to the third. And then we have times 5 and times 7. So this is the prime factorization of 945. All right, so now I'm going to find the prime factorization of 5145. So I'm going to type 5145 divided by 5, and that gives me 1029. All right, and then same thing, divisibility rules. I can see that this number is divisible by 3. So since 5 is prime, that one will stop. We will divide by 3. So I'm just typing on the computer divided by 3, and that gives us 343. So 343. And then I believe this number is divisible by 7. I want to say that's one I'm familiar with. So I'm going to divide that by 7. That's going to give us 49. And then 49 is 7 times 7. All right, so this prime factorization is 3 times 5, and then we have 1, 2, 3 sevens, so it's going to be 7 to the third. Okay, so that's that prime factorization. So once you get both of them, you're going to look and see what do they have in common. Okay, we're only going to take what they have in common. So when you write in factorization form and you have the exponents, you're going to list all the numbers that they have in common. So both of them have a 3, both of them have a 5, both of them have a 7. So the greatest common factor, GCF, is going to be, and this is just part of it, 3 times 5 times 7. You start there, and then you compare them and you take the smallest exponents. So I know greatest you would think bigger, but that's the way my mind helps to describe it. You're going to take the smaller of the exponents. So looking at the two threes, This one would be understood to have an exponent of a 1, that one have a 3. So the smaller one is 1, so we only want 1 3. And then of the 5s, they both have the same, so we just need 1 5. And then of the 7s, the smaller one is just the 1 7. So we just need 3 times 5 times 7. And you actually have to multiply that out, and that will give you 105. Let's double check that. 3 times 5 times 7. Okay, we get 105. So this is what you want to say is your greatest common factor, 105. Now, the other method is called a box method. So with the box method, we're going to write both those numbers in this box. 945. We're going to skip some space, and we're going to write 5145. All right, we're going to take both these numbers and see, okay, what can I divide both of those numbers by? Well, 5 again, so that's what we started with. I'm going to write 5. And then, when we divide this by 5, we get 189. And then over here, we get the 1029. And then we would do another box. And then we say, okay, what can both of these numbers be divided by? Okay, so the next thing we did was 3. So we can divide them both by 3. And then divide by 3, we get 63. And then divide by 3, we got 343. All right, and then we make another box. And then we say, okay, what can both of these numbers be divided by? And both of them can only be divided by 7. And then write the result, we get 9. Write the result, we get 49. And then I would do another box and see, okay, can I divide both of these numbers by anything? And then there's nothing. This one is divisible by 3, this one is by 7. So once you get to the end, then you only take the numbers that you divided out, which are 3, 5, and 7, and if you multiply those together, that's the same thing that we got up there. So you can just do both of them at the same time and just divide and keep dividing until you have no more common factors, and this is your greatest common factor at the end of the day.